I'm Johan. I'm a software engineer working at Uber, and with me I got Wesley.
Hi everyone. Yeah, my name's Wesley. I'm also working together with Johan at Uber on our stateful container platform.
Yes, and we're going to talk a bit about not forking around or leveraging NRI to extend Kubernetes at scale. Essentially, we're going to talk a bit about our container platform and how we are trying to do certain things on Kubernetes that we haven't been possible to do before. So, does it work? Uber does 1.5 million trips per hour. We do this across like 70 countries, and that's both for like rides and delivery. Underneath all of these rides are, of course, a lot of containers. So we have 8 million containers that are running on more than 200,000 hosts. And we do this on multiple platforms. The Uber stateful platform is a platform that both Wesley and I are working on. We're running 400,000 stateful workloads across 3 million containers and on 100,000 hosts. But at Uber, we have multiple different container platforms. The stateful one, of course, runs databases, storage systems, anything that relies on local disk or persistent volumes in general. We also have a stateless container platform that runs services, APIs, microservices, and anything else that doesn't require state. Then we also have a batch processing platform, which does all kind of like data processing and analytics as well. The last two, they have already been moved towards Kubernetes and are running on a Kubernetes platform. But our stateful platform has been like a proprietary built container platform, and we now trying to see, can we actually move that towards Kubernetes? It's the last major holdout. And by trying to unify all of these different platforms on Kubernetes, we get this kind of common layer where we can reduce fragmentation and enable a lot of like common tooling and basically get observability and policy and service mesh and all of these different things, get them unified to run on top of Kubernetes. The challenge is that on our proprietary container platform, we've been able to build a lot of different sort of integrations that we needed to run to basically build our stack. And these features, they are now dependent on by a lot of these stateful workloads. Kubernetes might not have all of these features available. So essentially, the business doesn't care about pods. All of these features that we built, they set some kind of like expectation. The stakeholders, they rely on them, and the platform in general depends on them for efficiency. If we end up regressing on a lot of these features, this is going to be quite costly to the business itself. So these features have been shaped, basically been shaping our platform over the last almost a decade. And one of the major things is that we've been using locally attached disks. We've been running on our own data centers, on our own hosts. We've had the disks available, and by using the locally attached disks, we got low latencies and high throughput. But unfortunately, now we have a lot of stateful workloads that are depending on this. And by having locally attached disks, it also makes it much more operationally expensive to try to move these workloads from one host to another host because we need to replicate the data. As such, we've been trying to do more mutability. We want to do any sort of like in-place changes to all the resources and configurations of these workloads, if at all possible. So to give you a couple of examples, we want to be able to do more mutation of resource controls. We're trying to here use C groups, essentially being able to specify the CPU and memory using CPU sets. We want to do over-allocation of CPU, so allowing for bursting, even though we're using CPU sets. And we want to be able to have essentially workload level or pod level resources. We also want to be able to specify some container controls, essentially having more control over these containers, such as like adding and removing the containers in place. We want to be able to have container labels and like dynamic, essentially container labels per container. This is to have like a better and deeper integration into some of the existing Uber infrastructure stack. We also have some container runtime policies, such as OOM score, so being able to adjust which containers do we OOM at which point. and being able to have processes schedule priorities to have priority of containers within any given workloads. These are features that we've been building on top of into our existing container platform. And a lot of these workloads are now depending on this to have much higher availability and like higher throughput in general. So what we're seeing today is a gap between the ideal, the reality, and the pressure. The ideal, of course, would be to have all of these features native available on Kubernetes. The reality, though, is that Kubernetes is a big project. There's many. It's difficult to get these features into Kubernetes without them actually having been proven and actually have these use cases out there that not just us, but like many other companies might be able to say, hey, we need this feature. At the same time, we also have some pressure to try to see, can we do some of this unification? Can we leverage all of these internal things that is but trying to move towards Kubernetes? And in general, just try to see, we need to move the goalpost, and we need to try to fix these issues internally first. So when you're at a big company, you sometimes can have like a bit of a temptation and see, well, we can fork Kubernetes. We can make all of these problems go away by actually adding these features into Kubernetes directly. We have full control. We can get the immediate results, and we can deploy it out and see we have actually an Uber-tailored solution. But of course, forking is not always the right decision. It means that we might have slower upgrades. We need to have all of these upstream changes. We need to make sure they are compatible with our internal changes. We need to verify every single commit. Does that actually break anything internally? It also means that we're a bit more isolated from the community at large, and we accrue this long-term technical depth by having our own fork. The latter two, we've already been seeing that by having our own container platform, and we would like to see, can we actually unify and be actually using more of the upstream features instead. So again, the best would be if you could just upstream all of these features. But as mentioned, these are like Uber-specific features. It's not necessary that the community at large actually needs them right now. We would actually need to prove them and have them write a cap, get them out there, see if it actually makes sense to add these features, and for more companies to say, hey, this makes sense. And we have a bit of urgency, right? I think most of us knows that when the business says we need something, we try to get the work done, and then we need to do that in a way that makes it forward compatible. So with that, I'd like to get Wesley on to talk a bit about how we do that.
Thank you, Johan. All right, so Johan set us up pretty nicely on the problem, like what is the issue with forking Kubernetes, and we have all these specific use cases that we would like to get implemented for the business. So what exactly is the way forward? So the way forward is the Node Resource Interface, or NRI for short. Quick show of hands, how many of you people have heard of NRI before this talk? Wow, okay, quite a few actually. Nice. But yeah, up on the screen I have a definition from the Containerd GitHub repo, just explaining what it is. But yeah, in essence, it allows us to hook into the lifecycle of the container and make changes. So yeah, just kind of want to walk over this, like how this happens. So the first question is, what exactly do we need to create a container? The first thing we need is a container runtime. So this is often something like run C, Kata, there's other ones as well. But this is like the low-level component that does all the heavy lifting, interacts with the Linux kernel, and it's the one that like creates the container at the end of the day. As an input, this takes an OCI bundle. So this, you can think of this as like the recipe for the container. So it contains like resource requests, device mounts, other configuration that we need. So it tells the container runtime what we need to create the container. And the power of NRI is that we can change this before it makes its way to run C. I think this will be a little bit easier if we take a look at all of the components involved. So let's go ahead and do that. So up here on the slides, I have several components, so we all know what a pod is. I hope we're at the KubeCon. So whenever you create a pod, it has like a list of containers, and then the kubelet sees that. So the kubelet's watching the pods. It sees, okay, I want to create some container. The kubelet then reaches out to containerd, and it says, please create this container. And then containerd also processes that request. It also watches the container. You can get like some status updates and so on. It sees that and then forwards the request to the container runtime that I mentioned earlier, and then you have your container. NRI lives in this part here, so the CRI runtime. If you remember, the quote was from containerd. Containerd also worked on this implementation. So if we take a closer look here, on the left we have the request that comes in from kubelet. Then we have the node resource interface. It lives here, so the containerd provides the infrastructure to hook into this lifecycle. And then we can register one or more plugins if we want to. So I'll have a demo later. We'll only have one plugin, but you can have multiple plugins. So the request comes in, containerd forwards the request to the NRI plugin, and from there we can make changes to the to this OCI bundle, essentially. So we can make changes to the container. We can give it more resources. We can add some volume mounts. We can change cgroup configurations. We can do a lot of stuff here. So it's very powerful. Then we respond, and then we have the changed OCI bundle. So we've hooked into the lifecycle here. So the NRI plugin, it's quite a powerful tool. But somehow we also have to tell it what to do. So we want to be super declarative, and like I know we're using Kubernetes, we want to make declarative things. So at Uber, we made something called a pod extension. So it's just a custom resource definition. And for this case, we could define a lot of the features that we needed. So one of the features that we needed was pod level resources. So at the time when we were making this was not in upstream Kubernetes yet. So this was one of the features that we needed, and this is something that we expressed in this pod extension resource. And we used the NRI plugin to support this. So then we can also set like other configurations as well. So like going along with the pod level resources example, we can set resources on the pod level and say, please only use 10 CPUs. At Uber, we're also using CPU sets instead of CPU quotas. So that was also like another thing that we used instead of the default Kubernetes behavior. We can also configure each of the containers separately, so then we can also add like additional, so for this example here on the screen, we have container foo. It can only use up to 4 CPUs, and then the last container bar, it's unbound. It can use all of the pod level resources if it needs to. You might also be thinking like how does scheduling work in this case if we're not putting any resources on the pod. So we also had our own like scheduler that was external to this, making all the decisions and scheduling the pods, and it was also creating this pod extension resource for us. So yeah, let's try to go through the flow of how this looks. So we had some controller making a pod and a pod extension resource. We have the kubelet, so like the picture from earlier, the container gets sent to kubelet. We go to containerd, we have the NRI interface here, and we forward the request to our node plugin. So then we have our Uber-specific node plugin, and we also know which pod the container belongs to. So we can look up the container, we figure out which pod it belongs to, and then we can also look up the pod extension resource, and then we can get these configurations that we've specified in the pod extension resource. We reply. We've made changes to the container now, and then we can forward this to run C and have our container that's been changed under the hood essentially. Then we have the scenario, what if the container is already running? Because the diagram that I just showed you, that was like on the creation flow. So if the container is already running, we can make an update to so we can update the spec of the pod extension. And since the NRI plugin, like we can just turn it into a daemon set. It can be a controller. It can access the Kube API. We get the resource. And we can look up the container, and then we can make the changes. So the NRI exposes this API called update containers, and then we can essentially do like out of band requests to the container. And then we make changes to the container runtime. So there we can change the resources, inject devices, and some other things as well. Yeah, and then as you can probably tell, kubelet was completely out of this picture and not making any changes here. All right, that brings us to the demo. So let me just show you a quick architecture of what we're going to do. So we're going to use the Node plugin and do some vibe-based infrastructure because we're all using AI here. So what we're going to do is we're going to do the creation flow. And we have an NRI plugin, and the NRI plugin is going to call out to OpenAPI. And yeah, some LLM is going to decide how many resources our pod's going to have, and it's going to add some environment variables and some emojis because, I don't know, vibes. All right, so I have a kind cluster here. So let's hope this all works because we need the internet connection to cooperate, and we need OpenAI to cooperate, and a bunch of other stuff. So let's see. So we just have a normal Kubernetes cluster here. First thing I want to do is I just want to create a pod. Typing and speaking into the mic is a little bit challenging. Thank you. All right, so first thing I'm going to do is I'm just going to create an Nginx pod. So this is just a very normal pod, and there's going to be no changes here, so that we should just expect nothing out of the ordinary. So I applied this test workload here. So as you can see, it's just demo Nginx, nothing crazy here. I want you to remember we have 200 millicores as the limit that's been set. Yes, then I also have a script because what we're going to do is we're going to use the containerd CLI, CTR. I can never remember how these commands work, so I have a little script to get it here. So first we need to get the container ID. This is the container ID. And then we query it using CTR, and then we can check the resources. And then we see our quota here. It's 200 millicores. So nothing crazy and out of the ordinary. And we can also check the environment variables, and it's just a normal Nginx configuration. So nothing crazy here. All right, now I'm going to deploy our we'll deploy a daemon set with our LLM plugin. So up here we have our NRI LLM plugin that will add vibes to the container. Let's delete our demo pod and do this one. We delete the pod, and then if we apply it again, and then also if we get the logs, we should see, okay, nice, everything worked. So right now I'm checking the logs from our from the plugin, and we call this create container hook. So we've hooked into the life cycle of the container, and we sent it off to OpenAPI, and then we got a response from the LLM, and it decided, okay, instead of 200 millicores, we should have 500 millicores. We also want to bump the memory limit, and we also have some environment variables here as well. So we have the little star emoji, and like, stocks go up and to the right, and a little heart here, welcome to Nginx. And then there's also like some nice reasoning here, very important for our infrastructure. If we use our containerd script again, we get the pod, container ID, we exec, check the environment variables first. Yeah, so I told the LLM to add emojis because it's, first of all, vibes and LLMs, and then also it's easier to show in the demo. So we do have some environment variables that got added here. And if you remember, we just, there's no environment variables here in the manifest that we applied. So these came from the LLM that we injected after the fact. And then same thing with the resources. Whoops. Let's try to find this here. Yes, resources. And then, oh no, that was the first. Yes, this one. So we've also bumped the resources to 500 millicores. So the NRI plugin also changed this as well. How much time do I have? I still have a little bit of time. Yeah, so as you can see, we have this plugin here, and we updated the pods. We can also maybe just do one more just for fun. So if we can do like a kubectl run. We can make a very important pod and then see what the LLM decides to do. Okay, it's thinking, okay, yeah, now, yeah, very important, production, rocket ship makes sense. Important for not debugging anything, yeah, and time zone UTC, yeah, makes sense. Yeah, also, yeah, I didn't set anything, so these are unset, and then, yeah, I don't know, I ran this a few times. For some reason, the LLM really likes to give everything 500 millicores. I don't know why, I guess the training data that it was using. Seems to always give them 500 millicores, but yeah, that's besides the point. Yeah, so one final thing. So yeah, we saw that we updated the pods. We can also just take a quick look at what I was doing in here. So we call OpenAI, and then yeah, this is the prompt that I was using. So I was just so we get the container intro from containerd. So then it calls this create containers, and then eventually we go to this part where I build the prompt, and then yeah, I told it to analyze this container, and then also to always return a JSON, and then yeah, also please explain why, and then yeah, also to add emojis for yeah, an improved demo experience. Cool. Yes, I think that's everything I wanted to show you for the demo. You can take this. Thank you very much, Johan. We can go back to the slides. Yeah, so our amazing vibe-based infrastructure. Just note, I only showed you the create flow. In theory, we could also do like some updates as well, but it's easier just to show the create flow. Okay, yeah, back to slides. So let's recap. What does NRI give us? NRI gives us a hook between Kubernetes and the containers, and also like a way to mutate our containers in place. So it's a very powerful tool. Also at the same time, it allows you to, as you can imagine, to like shoot yourself in the foot, because it's very powerful. You're doing stuff under the hood. Kubelet doesn't necessarily know, but like it's a very powerful tool. And yeah, it was very helpful for us to solve a lot of these challenges that we mentioned earlier. Yes, now we're deprecating NRI, so we're not using it anymore, or we're trying to move off of it. And this is because, like I mentioned, it's kind of like it's a foot gun. We don't want to shoot ourselves in the foot, but it is a very powerful tool. It was definitely the right choice for us to use. But we also had an exit plan along the way, because we knew this should be like a short-term solution. We want to upstream the changes we've made. Yeah, so yeah, we came in with an exit plan. So yeah, this was our exit path. Obviously, the easiest thing to, like, if you want to stop using a certain component, just stop needing to use it. So we can adjust our requirements. Yeah, so some of the specific features that we needed, like adding container logs, it's not something super, or container labels. Sorry, we needed that to add logs, but yeah, adding container-specific labels was not something that was super fundamental, so it's just like a feature that we could drop. And eventually, we can also add other features to Kubernetes upstream that we could then use. And then if we're using core upstream Kubernetes and it uses all of the features that we supported with the NRI, we can just drop the component. And then eventually, at the end of the day, we have no more NRI, we have amazing features in upstream Kubernetes, and we're all happy and not forking Kubernetes. All right, let's do some quick lessons and takeaways that we learned from this. So like I mentioned, for Uber, I think it was definitely the right choice to use this. It definitely unblocked us. It helped with our migration. It was very, very useful. With that being said, should you use NRI? Let's go for some reasons why you shouldn't first. So if you're thinking, and if you're sitting there thinking like, should I use NRI? Maybe consider these things first. So first of all, like you're going against the grain. As you can imagine, like maybe you had like a little bit of like an icky feel, like, oh, we're making changes like under the nose of Kubelet and we don't really know what's happening. So that's definitely something that's happening. We're also essentially making pods much more mutable, which was very important for us, but it goes against the grain. It's not what Kubernetes is meant for. Then we also have added complexity, obviously, like it's another component that we need. So if you're adding complexity there, it's also a very low-level component. And if you break something there, you can easily break a lot of stuff. And then, yeah, you should probably also consider changing your requirements. It might be easier than implementing this at a large scale. But it is a tool in the toolbox if you want to consider it. Yeah, some why it might work. So yeah, like I mentioned for Uber, it unblocked us. So if there's a very specific feature you need or a very specific use case, and it's like some clear requirements, then it's definitely something you can and yeah, maybe should use, but definitely think about it first. And then also maybe have an exit path if you want to upstream the feature eventually, or just yeah, have an exit path at the end of the day. And like most things, there's trade-offs. So you have to ask yourself, like, does the added complexity make sense? Do I want to have this extra component? Can I do something instead? Is what you should be asking yourself at the end of the day. Yes. If you want to check out the containerd NRI repo, it's there. Also the Uber blog. If you want to see other challenges that Uber solve, we also have a cool blog with cool engineering topics. So feel free to check it out if you want. Yeah, that's this one. Yeah, and with that, yeah, I appreciate your attention and listening to us. And yeah, thank you.